What I want to do is try and experiment and see if we can figure out why we get different seasons. Now remember, the Earth spins like this, and it stays at this angle all the way around the sun. So during the time of the year that we call summer, which would be June, the sun's over here, and so the tilt is towards the sun, so it puts the US, so we get direct sunlight. During the winter, sun's in the middle, it's over here, you bring the US around. Now the US is way up there, so the direct sunlight is down in Brazil, and we just kind of get a crooked skiff of sunlight, so we don't get as direct sun. But there's more than just that. Let's see if we can put the light on here. Can we dim these just a little bit, please? Okay. Light us up.
Where do you want it?
I want it on the Earth. Okay, good. You can see that this side of the Earth is having daytime. This side is having nighttime. And we look at the spin. The spin is so that the southern hemisphere is getting the direct sun. So I've got this set up now. If that were the sun in this relationship, this would be winter, okay? If I turn the spin around, which it would do by going halfway around the sun, then the Earth would be tilted so that the United States is facing the sun. And here's something interesting. If you look up here at the very tip top, which is the North Pole, you can see that it's in the sun. And now I'm going to have a 24-hour day. The Earth is turning like it does 24 hours, but you notice there's always sun here. And during the summer, the sun never sets at the North Pole. You say, well, wait a minute, why is that? Well, it's because it's tilted. If it was tilted like that, it would never set either, but it's not tilted quite that far, but it's tilted enough that it never sets. But look at the South Pole now. It's in the shadow all day long. So during our summer, during the month of June, July in the United States, up in North Alaska, the sun never goes down. And during the winter, if you turn it around up in Alaska, now the South Pole never gets dark, but the North Pole is always dark. The sun goes down in the fall, late fall, up at the North Pole, and they see it go down, and they know today's the last day we see the sun until the beginning of spring. And think about that. Now, I saw that when I went to lecture about hydrogen in Anchorage. I flew up right in the middle of winter.
Oh.
Big mistake. But I flew up there in the middle of winter, got out, it was really cold. People parked their cars at a little meter, and they'd get out and plug in a cable to keep their car warm so it would start when they came out. That's how cold it was. It was really cold. But in the morning, you could see over there on the east where the sun should be coming up, it was still dark. And you watch and watch. And about 11:30, finally it started to get a little bit light over there, like before sunrise. And boy, I was excited. I was ready for the sun. I was ready for the sun. And it got a little lighter, but before the sun came up, it started getting dark again. So it just got a little teeny glow on the east part of the sky, and then it was gone. And that was it. And yet during the summer, and I haven't been to Alaska in the summer, which I should do because it's a beautiful place, but during the summer, the sun comes up, and at night, it just goes down almost like it's going to set, but it doesn't quite, and it just starts coming right back up. Because, as you can see, no matter how you turn the Earth, the light's still on the North Pole. So it's this turning at an offset angle as we go around the sun that makes the seasons.